Explicit function is a function in which dependent variable can be written explicitly in terms of independent variable. So as the definition says, you can see that a variable is isolated and it is defined by another variable. So those kind of function is known as explicit functions. Now in regards to implicit functions, they are just opposite to the explicit functions. It is a mix of functions. So variable, as you can see in the definition, it is a function in which the dependent variable can't be isolated on one side of the equation. Hence, you can see here, even in the examples, different variables are mixed, and you can see that the independent variable and the dependent variable, they are together as well, right? So this kind of functions is known as implicit function. Now, to differentiate those implicit functions, first let us look at few examples on how to differentiate explicit function. For example, differentiating y equals to 2x plus 1. Here differentiating y with respect to x, because here the variable y is the dependent variable and x is the independent variable. Now, keeping the coefficient aside, you just focus on the variable and differentiate that. So we are now getting, when we differentiate this, you will get 2 times 1, because differentiation of x with respect to x is 1, and differentiating of constant is 0. So we have differentiation of 1 with respect to dx is 0. So finally dy over dx is equal to 2. Now this example would tell you that it's not always y that is a dependent variable. So it is not the variables we are focusing on, but the understanding that which one is independent and which one is dependent. Now you can see that variable u out here in the example is a dependent variable because it is alone, and moreover u is being purely dependent on the value of v, right? So this kind of explicit function, if you have to differentiate, so differentiating u with respect to v, so we are differentiating the whole equation with respect to v. So see here, du over dv is equal to, now differentiating v square would be bringing exponent in front, then from the exponent 1 gets eliminated, plus equation 2 remains like that. So differentiating v with respect to v is 1, and minus differentiating a constant will give you 0. So the final answer we have is 2v plus 2. Another example of implicit function. Now differentiating x, which is raised to half, minus differentiating y with respect raised to half with respect to x, plus differentiating 3 with respect to x equals to 0. Now here differentiating x with respect to x is pretty much easy, because you just have to put exponents in front, then from the exponent one gets eliminated. So that is what happens when you are differentiating a variable with respect to the same variable. When it comes to differentiating a different variable with respect to a different variable, there, if you remember chain rule, it would make it more easy. Chain rule. So chain rule means to get, okay, so your aim is to differentiate y raised to half with respect to x. So for this, because you have different variable, you cannot follow up what you did earlier with the first term. So the problem here is, when I differentiate y raised to half, I need to differentiate this with respect to y only, right? Now just because I need dy in the denominator doesn't mean that I can just change dx directly to dy. It is not possible. But what I can do is, I need dy in the denominator, so I created it. Now I also need to have an additional term, that is a numerator which has dy, so that it won't make any difference introducing dy in the denominator here. Now to make it same, you have here dy raised to half in the numerator. Now in the denominator, this and numerator in here will get cancelled out, so which means the place for dx would be here. So I hope you are getting this, right? So which means to get this product here, I can multiply these two things. So which leads me to now y. See, differentiating y raised to half with respect to dy means I can use the formula now. Exponents come in front, from the exponent one gets eliminated. So this is the first term value, that is times. Now I can just keep dy over dx here, not a problem. So this is equal to 1 over 2 y raised to negative 1 over 2. Then we have dy over dx. So you have the value of this as what you have got here. So you can just put this one out here. So you have 1 over 2 y. So instead of writing y raised to negative half, I just change the exponent, and which will sign of exponent, so that means it will come in the denominator, and half is square root, so I'm changing it back. Then I have to also mention dy over dx, then plus 0 equals to, because constant differentiation is 0, right? So finally I have 1 over 2 square root of x minus 1 over 2 square root of y dy over dx equals to 0. So if I want to make dy over dx separate, if I want to separate that, I need to make it some arrangement here. Then negative gets cancelled, so you have dy over dx equals to, the denominator here gets multiplied with the numerator, so 2 square root of y divided by 2 square root of x. 2 gets cancelled, so you have dy over dx is equal to square root of y over square root of x. So this is the answer. Please check out the part 2 video for clear understanding, where I have solved one more example on implicit function differentiation.